In this lesson, we're going to talk about the Pythagorean Theorem. The Pythagorean Theorem regards right triangles and the relationships among the side lengths. So in order to talk about this, let's look at a right triangle briefly as a reminder. A right triangle has one 90-degree angle, also known as a right angle. Across from that right angle, we call this side the hypotenuse. It's always the longest side of a right triangle. And then the two sides that make up the right angle we call the legs of the right triangle. The Pythagorean theorem is then set up using this same idea. If you look at the hypotenuse and the two legs of the right triangle, if we call them A and B for the legs and C for the hypotenuse, then you will say A squared plus B squared equals C squared. This formula applies for any right triangle. One thing when you're using this formula is make sure that you get your variables straight. A and B are the two legs and they can be interchanged. It is addition after all. But C must be the hypotenuse, the side across from the right angle. If it's not, this does not work. Let's use the Pythagorean theorem to find the length of the hypotenuse of this right triangle. Again, the idea is C should be the hypotenuse, which it's already labeled. And the other two you can just call A and B, whichever way you would like. The Pythagorean theorem is again A squared plus B squared is equal to C squared. And then we'll plug it in. 3 squared plus 1 squared is equal to the C squared that we don't know. Then we just need a little basic algebra here. 9 plus 1 is equal to C squared. I'm going to flip this around and say C squared is equal to 10. And to get C by itself, we'll take the square root of both sides. This gives us C is equal to the square root of 10, but it would be nice to approximate that. The square root of 10 is approximately 3.16, and then let's put a unit, centimeters. You'll notice that this length is more than the length of the two sides, which should be the case. It should be the longest side because it's the hypotenuse. Let's do another example. We've got an unknown length labeled x. Now x is not the hypotenuse this time. The hypotenuse is the 20, so let's label that C. X, I'm just going to call that my A, and 13 I'll call my B, and then I can use the Pythagorean theorem as normal. Plugging in my values, A is x, B is 13, and C is 20. Let's calculate these. X squared plus 169 is equal to 400. Now a little bit more algebra. Let's subtract the 169 from both sides. And that will give us x squared is equal to 231. Same as last time, I'll now take the square root of both sides. I get that x is equal to the square root of 231, and then let's calculate that. I get that this is approximately 198, so that rounds up to 20 inches. This brings up an important rounding idea. You know that if you see 198, you should round up on the 8, which makes the 9 go up, and then you get a 2. The thing I want to point out is that I put 20. Why did I put 20? That shows that I still rounded to 2 decimal places. Even though I could just write 15.2, saying 15.20 says, yeah, that was 2 decimal places where we got the 15.2. Even though this section's a little bit brief, the Pythagorean theorem will come up in a few of the problems we need to do in the future.